Hi students, welcome to my YouTube channel AS ELECTROCHEMISTry classes. Please subscribe and press bell icon to get notification. Okay. In the first video, we discussed about quantitative aspects of electrolysis. Today, we have to discuss the remaining portion of electrolysis. Listen, we know a very simple point, 1 Faraday equals 96,500 coulomb. We know this relation. Now today, we have to solve different type of problems asked in different entrance exams. Now here, a simple question. Now here is a question. Consider conversion of MnO4 minus to Mn2 plus. You see this reaction. How much Faraday is required for this conversion? Permanganate ion is converted into Mn2 plus. How much Faraday is required for this conversion? How can we solve this problem? A very easy technique. You see, find out the oxidation number of manganese. Suppose manganese oxidation number X. Then oxidation number of oxygen -2. There are 4 oxygen, so total -8, sum should be equal to -1. On solving, we get X equal to -1 plus 8, that is equal to +7. Here, oxidation number of manganese +7. Here, oxidation number of manganese +2. Okay? Now find out the difference between +7 and +2. Tell me, what is the difference? It's very simple, 5. So, this reaction involves how many electron? 5 electron. Conversion of MnO4 minus to Mn2 plus utilizes 5 electrons. So, this reaction involves 5 Faraday. Number of electron 5. So, very easy technique. Number of Faraday will be 5. To convert 1 mole MnO4 minus to Mn2 plus, it requires 5 Faraday of electricity. To convert into coulomb, we know that is 5 into 96,500 coulomb. Now here is the final answer. Clear? You see, conversion method, number of Faraday can be calculated by this method. To make it more clear, consider another example. You see, dichromate ion Cr2O7 2 minus converted into Cr3 plus. To balance, we should write 2 Cr3 plus. Dichromate ion is converted into Cr3 plus. How many Faraday are required for this conversion? How can we solve this problem? Just like the last problem, find out oxidation number of chromium. There are 2 chromium. So, oxidation number of chromium, take it as 2x plus oxidation number of oxygen -2. There are 7 oxygen, so total will be -14, that is equal to -2. Clear? From this, we get 2x equal to -2 plus 14, that is equal to 12. Then x equal to 12 by 2, that is 6. Oxidation number of chromium, now here on reactant side +6, then oxidation number of chromium on product side +3. Now how many Faradays are required? Listen, here there are 2 chromium, so we should consider total charge of chromium. Charge of 1 chromium +6, total charge of 2 chromium, 6 into 2, 12. Here total charge 12. Here 3 plus 1 chromium, 2 Cr3 plus, so total will be 6. Listen, reactant side total charge 12, product side total charge 6. Then what is the difference? 6. So how many electron? 6 electron. Then how much Faraday is required? A very simple, 6 Faraday. Conversion of dichromate into Cr3 plus utilizes 6 Faraday. To express the answer in coulomb, we know 6 into 96,500 coulomb. Now here is the final answer. Now we solved 2 problems, conversion of permanganate into Mn2 plus, conversion of dichromate into Cr3 plus. Clear? In the same way, we have to solve organic questions, organic reactions. You see an example. Consider reduction of nitrobenzene. Reduction of nitrobenzene to aniline. Now, this question asked in JE exam. 1 year JE paper, this question asked. Conversion of nitrobenzene to aniline. How much Faraday is required? How can we solve this problem? Just like the last two example. Find out the oxidation number of nitrogen. We know oxidation number of oxygen -2. There are 2 oxygen. So total will be -2 into 2 -4. So oxidation number of nitrogen will be +4. In nitrobenzene, oxidation of nitrogen +4. Now here, oxidation number of hydrogen +1. There are 2 hydrogens, so total +1 into 2 +2. Hence, nitrogen will be -2. You see on both sides. Here, oxidation number of nitrogen in NO2 +4 and that of nitrogen in NH2 -2. Then what is the next step? Find out the difference. You see, +4 and -2. What is the difference? 6. So, how many electron this reaction involves? 6 electron. We know if number of electron is 1 Faraday. If it is 2 electron, require 2 Faraday. Here number of electron 6. So this conversion involves 6 Faraday. To express the answer in coulomb, 6 into 96,500 coulomb. Now here is the final answer. I hope you are able to find out the number of Faraday required for conversion reactions. Clear? Now I will give you a simple numerical problem based on this concept. Here, one question from previous All India Medical Entrance Exam. The question is like this. You see, 4 Faraday of electricity. 4 Faraday of electricity is passed through 4 Faraday of electricity is passed through water. Calculate total volumes of 2 gases collected at STP. You see the question? 4 Faraday of electricity is passed through water. Calculate total volumes of 2 gases collected at STP. Then find out the answer. Or how can we solve this problem? You see, first you know number of Faraday 4. Then what are the 2 gases obtained by electrolysis of water? Very simple thing. On electrolyzing water, we get 2 products, then 2 gases, hydrogen and another one oxygen. So we have to find out what is the volume of hydrogen collected, then what is the volume of oxygen collected. You see, what are the steps utilized for solving this problem? We know hydrogen ion, that is H+. Then in the last video, I told you that hydrogen is diatomic, so we should write 2H+. 2H+ converted into H2. You see, number of electrons involved 2. So this conversion requires 2 Faraday of electricity. So we get a relation. You see, 2 Faraday will produce 1 mole H2. Alright, you see, 2 Faraday will produce 1 mole hydrogen. We know 1 mole of gas at STP will be 22.4 liter. So I write 22.4 liter. 2 Faraday will produce 1 mole H2, that is 22.4 liter. But in question, 4 Faraday given. Therefore, you see, 4 Faraday will produce 2 mole H2. That means 44.8 liter. Now we get one answer. Volume of hydrogen 44.8 liter. Now we have to solve the remaining part. That means what is the volume of oxygen collected at the same time? You know, just like oxygen, just like hydrogen, oxygen is diatomic. Now here is the reaction. Oxide ion 2 minus, then 2O minus, converted into O2. It is the conversion of oxide ion. Then you see the charge. Then we can see it requires 4 Faraday because number of electron will be 4. Minus 2 into 2, 4. So number of electron 4. 4 electron means it requires 4 Faraday. Now here is the relation. 4 Faraday will produce 1 mole O2. How much volume? 22.4 liter. Question given 4 Faraday. You see, on passing 4 Faraday, we get 44.8 liter hydrogen, then 22.4 liter oxygen. Question, what is the total volume of 2 gases collected? So I write total volume of 2 gases. Total volume of 2 gases equal to 44.8 plus 22.4, total 67.2 liter is the correct answer. Total volume of 2 gases collected 67.2 liter. You see 44.8 liter hydrogen and 22.4 liter oxygen. Now here is the method of solving problem based on quantitative aspects of electrolysis. Clear? Now we can pass to next topic in connection with the electrolysis. That means a very simple topic. Faraday's laws of electrolysis. We have to study 2 laws in connection with electrolysis. We have to study one by one. Now here is Faraday's first law. Now we have to study Faraday's first law. Now what is Faraday's first law? Very easy one. We know. Consider a simple example. Now here is an electrolyte, sodium chloride, molten sodium chloride. Then consider electrolysis of molten NaCl. You pass electricity through molten NaCl. You know, as a result of electrolysis, we get 2 products, one at cathode and another at anode. On electrolyzing molten sodium chloride, we get sodium at cathode and chlorine at anode. Okay, suppose the mass of sodium obtained at cathode, let it be W. On passing electricity, we get sodium at cathode. Suppose weight of sodium obtained, let it be W. And charge passed through this electrolyte, let it be Q. Then remember Faraday's first law. Now here is Faraday's first law. W directly proportional to Q. That means mass of substance obtained during electrolysis is directly proportional to the charge passed through the electrolyte. Weight mass directly proportional to charge. Remove this proportionality sign. Now we get W equal to ZQ. It's a mathematical expression of Faraday's first law. What is Faraday's first law? Mass of substance obtained during electrolysis is directly proportional to the charge passed through the electrolyte. What is the law? W proportional Q. That means mass of substance obtained during electrolysis is directly proportional to the charge passed through the electrolyte. That is W proportional Q. Mathematically, W equal to ZQ. What is Z? Z is a constant called electrochemical equivalent. Then back to physics. We know Q equal to IT. You have to study in physics this relation. Q equal to IT. Q means charge, I means current, T means time. So first law can be written as W equal to ZIT. We get the second formula of Faraday's second law. There are two expressions, remember, one W equal to ZQ, another W equal to ZIT. It's mathematical expression of Faraday's first law. Now, we have to study a simple definition for Faraday's first law. A simple definition for electrochemical equivalent. You see, we get two expressions, W equal to ZQ, W equal to ZIT. From these two equations, we have to find out a simple, easy definition for electrochemical equivalent. Suppose here, Q equal to 1 coulomb. Charge passed through the electrolyte is 1 coulomb. We get W equal to Z. We get this relation W equal to Z. Now here suppose current passed equal to 1 ampere. I means current. Suppose current passed through the electrolyte is 1 ampere and T 1 second. Substituting these two values here, finally we get W equal to Z. You see, from this we can define electrochemical equivalent as mass of substance obtained by passing 1 coulomb of charge or 1 ampere current for 1 second. I shall repeat. Electrochemical equivalent is defined as mass of substance obtained by passing 1 coulomb of charge or 1 ampere current for 1 second. Now we studied Faraday's first law, definition of electrochemical equivalent, mathematical formula of first law, then definition of electrochemical equivalent. Now we should remember this formula Z equal to E by 96,500. Now here is a relation. Z means electrochemical equivalent and E means equivalent mass. E means equivalent mass. Electrochemical equivalent can be calculated as equivalent mass divided by 96,500. Then a doubt may arise, how can we calculate equivalent mass? There are different methods. Now here we consider equivalent mass of element. Now we discuss about element. Equivalent mass of element can be calculated as atomic mass divided by valency. Equivalent mass of any element can be calculated by using this formula, atomic mass divided by valency. Now I substitute a symbol for this. Atomic mass M, valency N. Now we get a formula E equal to M by N. M stands for atomic mass and N stands for valency. Now here an example. Equivalent mass of sodium. You see, atomic mass 23, valency 1. So equivalent mass of sodium is 23. Now equivalent mass of magnesium. You see, equivalent mass of magnesium 24, valency 2, that is equal to 12. Equivalent mass of aluminium, atomic mass 27, valency 3, so 9. Equivalent mass of silver, Ag. Atomic mass 108, valency 1, so equivalent mass will be 108. Now, in case of hydrogen, equivalent mass of hydrogen, atomic mass 1, valency 1, so equivalent mass of hydrogen will be 1. Remember, molecular mass of hydrogen 2, but here we consider atomic mass. Now, equivalent mass of oxygen. Atomic mass 16, valence of oxygen 2, so equivalent mass of oxygen will be 8. Clear? Now, we have to conclude Faraday's first law. Just recall mathematical formula of Faraday's first law. W equal to ZQ. Now here is one equation. That is W equal to ZIT because Q equal to I into T. I means current, T time in second. But Z equal to E by 96,500. So we get another equation. W equal to EQ by 96,500 or W equals EIT by 96,500. Here E stands for equivalent mass. Equivalent mass equal to atomic mass by valency. So W equals, again I rewrite, E can be written as MQ by N into 96,500. Students, please remember E equivalent mass replaced as atomic mass by valency. Now Q equal to IT, so MIT divided by N into 96,500. All these are different form of Faraday's first law of electrolysis. You see 1, 2, 3, 4, 5, 6 expression for Faraday's first law. 3 expression in terms of charge and 3 expression in terms of current and time. I hope you are able to understand Faraday's first law and its mathematical expression and definition of electrochemical equivalent. Now we can solve problems based on Faraday's first law. Now here a simple question once asked in All India Medical Entrance, 10,800 coulomb of electricity. 10,800 coulomb of electricity is passed through an electrolyte. It resulted in the deposition of 2.99 gram of metal. Resulted in the deposition of 2.99 gram of metal. Atomic mass of metal is 106.4 gram per mole. Calculate valency of metal. Calculate valency of metal. Now here is the problem. Once asked in All India Medical Entrance, students, you see how can we solve this problem? Certain data are given in your problem. You see 10,800 coulomb. Coulomb means charge. That means we get the value of Q. Q given 10,800. Then resulted in the deposition of, you see mass deposited given 2.99. You see mass deposited mean W. W given. Q given, W given, then atomic mass also given. Atomic mass means M given. 3 quantities are given. You see what are they? Q, W, M. Then what should be done? We have to calculate valency. Valency means find out the value of N. Then just recall Faraday's first law. Which equation is suitable for solving this problem? We know here is Faraday's first law. Here is an equation. W equal to MQ divided by N into 96,500. It is a proper equation for solving this problem from this. Just cross multiply and find out N. N equals MQ by W into 96,500. Just substitute the value 106.4 into 10,800 divided by 2.99 into 96,500. Students, on solving this problem, we get the value 4. It's an approximation. Correct value 3.9, but we know valence should be expressed in a whole number. So final answer 4. Then valency of this metal deposited is 4. Now here is the final answer. Clear? I hope you are able to understand this video in connection with the Faraday's first law. Then we have to explain Faraday's second law and its various problems that will be given in the next video. Please subscribe my channel and press bell icon to get notification. Thank you very much.